So this will be a very brief overview of the Scala programming language. Feel free to interrupt me whenever you have a question or you don't understand anything. I'll be walking through the main features of Scala and the whole reason why we'll be learning Scala, and what are some things which are unique to Scala which are not found in other languages. Scala is again an object-oriented language which is in the same vein as Java, and it runs on top of the Java virtual machine, the same way your Java program runs, and it is compatible with existing Java libraries. So that is the similarity of Scala with Java. You can run programs which are compiled in Java in Scala. For example, you have a jar which is already written in Java, and you can include that jar in your class path and then use the same function or API in Scala. So Scala comes in with a lot of backward compatibility with Java. So you'll feel at home. So like I said, Scala is object oriented. Scala is also bringing another paradigm called functional programming paradigm to its arsenal. Functional programming paradigm is in many ways trying to solve the same problems as posed by object-oriented programming. Like object-oriented programming was invented to improve maintainability, it fights complexity, it reduces the programmer burden, it improves the testability. Functional also does the same thing, except the approach is completely different. Objects are represented as real-world models in object-oriented programming. In functional programming, they are represented by functions. You know what is a function, right? Finding the square of a number is actually a function. So that is an example of a very simple function. So wherever you call it, it's going to return the same value. Like for example, you call square of 2, it's going to return 4 whenever you call it or wherever you call it. And Scala is a strongly typed language. What is a strongly typed language? Any guesses? Can you tell me what is a strongly typed language?
Not sure.
Scala is strongly typed in the sense that it doesn't allow you to coerce one data type into another like you have in PHP or JavaScript. You can define a lot of rich types and then run on top of it. And like I said, Scala runs on top of the Java virtual machine. So any Java library or jar which you have written in Java is compatible with Scala. So Scala already brings in the whole ecosystem of Java libraries along with it. You can use any popular Java library in Scala. So that's about Scala. These are the brief language features which are unique to Scala, which are not found in other JVM languages. I'll be going through them one by one. The first thing is type inference. Type inference is, like I mentioned, Scala is a strongly typed language. So every time you declare a variable, you have to declare that type in other strongly typed languages like Java. But in Scala, you need not declare the type. Scala can automatically infer the type from whatever variable declaration you have given. For example, the first two lines, val number int equals 5 and val name string equals Joe. You need not specify the type of number or the type of name in the declaration. You can just give number equals 5 and name equals Joe, and Scala is automatically going to infer the type of the string or type of the number for you. This saves a lot of typing work, and Scala allows you to focus on the business logic instead of declaring the types. So that's about type inference. You don't get type inference in languages like Java. Scala introduces the concept of higher order functions. The equivalent in Java would be you write a static class which exposes a method, and then you use that method as a parameter in other functions. An example would be sorting based on a specific criteria. The same can be achieved in a more lightweight and concise way using higher order function. Higher order function is a function which can be passed around like a variable. You can pass a higher order function as an argument to another function. You can make a function return a function. So that is another example of a higher order function. So in this case, there is a function I've declared here as toName. It takes a user type and then it returns a string. So what it does is it takes a user variable and then it returns the user's name. So here we have a case class called user. Case class is very similar to your Java class. It's more like a final class in Java. So what happens is I can use this toName as a parameter in users.map. So for every users in this list of users, it's going to map the toName function. So what happens is this will generate a list of strings. So if you give a list of users, it's going to do a map on the list and then it's going to produce a list of strings. So this is a very simple example of a higher order function. Most of the programming languages which you must have encountered have the concept of null. For example, if you want to query for a particular user and that function accepts the user ID as an argument and you go through the file or the database and then you return the user's particulars if the user exists, otherwise you return a null. Generally what happens in other languages is when this function returns a null, and when you are trying to dereference that null in some other place where you call this function, it's going to throw an exception, and you have to write exception handling everywhere you use this function. In the case of Scala, you have an option type. Option type is a programming construct wherein it denotes that the function can either return a value or it cannot return a value. So whoever is calling that function, the client can actually go ahead without checking for null, because he is not going to get a null. It's going to proceed to the subsequent steps only if the called function returns a specific value. For example, in this case we have a function which gets a user when given an ID, and we have a list of users called user map. So what user map, what we are trying to do in user map is we are trying to get a user called Bob. In our case there's a user called Bob, so it returns 2. What if we don't have a user called Bob? It's not going to return a null. It will return an option type wherein it indicates that the returned value might either contain a non-null value or it may not contain anything at all. So this is an example of an option type in Scala. Option type actually helps you in avoiding null dereferencing and other errors, and is very useful for error checking. Pattern matching is a construct which is there only in Scala, where you can actually match a given input with any other type. It looks like a switch case at first glance, but it is not switch case. You can even give complex expressions inside this case, and it can also be of different types. So this is a very simple example of a pattern match. So if the given user does not match anything, which is the case of none, you print that there is no user here, or if it matches something else, you print the age of that particular user. This is an example of a pattern matching application. Pattern matching can also be nested, and you can use it for more complicated business logic. You can use pattern matching in place of nested if-else statements. It's more useful than a switch case logic which you find in your typical Java or C++ program. So that's about pattern matching. So this is another non-trivial example of pattern matching, where you have a function which gets the age of a given user. So if the user matches nil, you return none. Otherwise you call sum of age, where sum will get the age of that particular user. For any other thing, you just call the same function recursively. Scala supports recursion by default because it supports first-class functions. So you don't have any performance penalties for performing recursion. So this is an example of pattern matching in a non-trivial case. if you look at this pattern matching code, we have used more sophisticated logic than what we do in a switch case typically. So this is the syntax for pattern matching: case, pattern, and then what action you have to take. This can also be a function. In this case, you have called the same function again recursively. Scala also has very good support for collections similar to Java. This is a very simple example. You just have a list of users, the same example I used previously, and you're filtering users whose age is greater than or equal to 25. So this is just a very simple function which takes an expression as an argument and then returns the same list. It's a trivial example of a collection. Here is one more example. Instead of a filter, I am using a partition here. Partition actually splits your list into two parts based on whatever logic you give her. This can be an expression, this can be a function, this can be whatever you want. So in this case, I have given an expression. So it partitions the given list into two lists, one less than 18 and the other greater than 18. So in our case, the list contains only users whose age is greater than 18. So we have two partitions, one an empty list, the other one a list of all users whose age is above 18. If you want to do the same thing in Java, you'll have to write a custom class for this and then write your own method and then pass that to partition and then declare it in a list. It comes to around 60 to 70 lines of code, and Scala we can get it accomplished in 4 to 5 lines. The main aim of Scala is to be as concise as possible. One more thing which I want to mention here is Scala also supports your REPL. REPL is read eval print loop. It has an interactive terminal where you can type in Scala code and get the output then and there. So as opposed to your general code compile and then run cycle in Java, Scala also has an interpreter mode which is called the REPL. You can just type Scala and then it will go to the interpreter mode. There you can type in your function or expression. For example, you can declare this list and try this line of code inside the REPL itself. If you find the code okay, you can compile it into a binary program. So Scala supports both interpreter mode and a compiler mode. This is one of the unique features of Scala. So this is the concise example of what I tried before. I have a user structure, and then I declare a few sample users, and then I write a function called getAge using pattern matching. Now I try to do the same thing using collections. So I reduce the code by a few lines. Yeah.
Okay, so are we going to cover about what is Scala, introduction to Scala in terms of what Scala can do, what's the architecture is, what is the use cases, and how the industry is using it?
Yeah, that will be the last.
Okay, okay, got it. Thanks.
I have a couple of slides reserved for that.
Okay, thank you.
So querying is one more advanced concept which we find in Scala. So what happens here is you can partially apply arguments to a function. For example, if a function has got 3 arguments, you can apply only 2 arguments and call one more function which will apply the 3rd argument. It's like fitting the pieces of a puzzle to form a bigger puzzle. For example, you might have heard of design patterns in programming languages like Java and C++. Wherein we give the business logic in different patterns like command and adapter and factory. You can actually get all those design patterns in Scala for free without writing a lot of code using the concept called currying. So here is a simple example of a currying function. Our objective here is to filter a list of integers based on a particular logic. So that logic can be that number should be divisible by 2 or number should be divisible by 3. So this logic is dynamic. So what we do is we give the logic as an argument to the filter function. So filter function takes a list of integers, of course, and then it takes a function which takes a number and then returns a true or false, whether that number is divisible by the number we pass as an argument. For example, I define a function called mod n, where it takes n as an argument and it returns whether the given number is divisible by n. So I pass mod n with the argument supplied as an argument to filter. So this way I can fit any logic here. For example, I can write one more function with the same argument types, which says whether a number is even or odd, and then pass it on to this filter function, and then expect a list of numbers which are filtered whether based on their even or odd. This actually ends up with a lot lesser code, and you can represent complex business logic using currying. Currying is one of the features which is present exclusively in Scala language. You don't find it in Java. You can do currying in Java, but you have to do it in a very roundabout way using a lot of design patterns. Currying avoids all that and writes your code in a very concise way. So that's about the special features of Scala. We'll be going through each and every detail separately and exclusively. We'll be writing a lot of sample programs in each and every concept. So my next slide will be how is Scala applied in industry mainly. So first thing is in the analytics space, we use a lot of Scala, especially for Apache Spark. Apache Spark is an improvement on top of Hadoop. It runs on a wider application space, and it runs faster than Hadoop, and it is slowly being adopted by a lot of big data companies as compared to Hadoop. Because we have a lot of business logic involved in big data in general. For example, you need to find the movie recommendations, or you need to find out the credibility of a person given his particulars. You need to write in a lot of business logic. So that is an exact problem space wherein Scala fits in. You can, like I said, you can represent a lot of complex business logic using very less code. So that's about Scala's use in analytics space. Scala is also used in a library called Scalding. Scalding is Scala's interface to cascading. Cascading is MapReduce abstraction based on Hadoop, which lets you represent complex programs without writing in terms of mappers and reducers. You can represent your business logic straight ahead, like using filters or special functions or count or aggregation, using simple functions instead of mappers and reducers. And scalding is an abstraction on top of cascading. Cascading is written in Java, and scalding is Scala's interface to cascading. So that is one more application in the analytical space where Scala is used. There is one more framework called Akka. Akka is actually a toolkit for building distributed and fault-tolerant applications on top of the JVM. You can think of it as Scala's version of writing components like Zookeeper and HDFS. So a lot of components in the Hadoop ecosystem are being rewired and rewritten in Akka. Akka is exclusively written in Scala and developed actively in the Scala community. In the web application space, Scala is used to develop a framework called Lift. Lift is an asynchronous I/O framework which is very similar to JSP or servlets. It is more modern. It supports asynchronous I/O. It supports a lot of data backends. It is more advanced than Spring, and it can also be written using Java. So Lift is one more application which is exclusively developed in Scala for the web application space. So that's about the major applications of Scala in the industry. That's it. Any questions?
So what about the architecture of it? Like, how does the Scala works? It's like only a language where we go and write the technology or the application, or
it's just a language like Java. You just have to go and write programs. That's it.
Okay. And Apache Spark is written completely on top of it. or how it is?
Yeah.
Okay, got it.